Hello guys, this is Sanjay Rathi. Welcome to Daily Ka Funda series. Today's topic is Darlington pair, that is common collector followed by common collector. And you will get idea why it is called super beta transistor. Stay tuned with me for next 10 minutes only. Okay? Then this is a Daily Ka Funda plus Daily Ka dose, and this is way to success series. Now guys, this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and I have trained more than 1 lakh students for competitive exams like GATE, engineering services and other PSUs through offline classes and through online classes. Then these are my ranks in engineering services exam: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I worked as deputy director in Ministry of Power on the basis of this results. Now this is my Telegram channel, that is Electronics by Sanjay Rathi. You can join for PDF of this session, and if you have any doubts then you can ask here. Link is given in description. Now guys, this is a Darlington pair where common collector is followed by common collector. These are the important points. At the end we will discuss all these points. Now what is the common collector followed by common collector? Remember, whether it is NPN or PNP transistor, watch this. We are giving input to the base, we are getting output from emitter, and that's why the first stage is common collector. Common collector is also called emitter follower. Then again this output will become input for the second one, तो ये cascading है. Then we are getting output from emitter, again input to base, output from emitter, that's why again it is a common collector. So common collector is followed by the common collector. Then we are getting the output here. So what are the advantage of Darlington pair? What is the purpose behind it? तो चलिए देखते हैं जरा. अब देखिए जरा, ये है second stage common collector, first stage common collector, and we have to find input resistance at this point. That is the overall input resistance or input resistance of the first stage, and overall current gain, overall voltage gain. It is second stage, it is first stage. Now for any common collector, voltage gain is nearly equal to 1. That's why it is called emitter follower. तो second stage का voltage gain है V0 upon V01. तो V0 upon V01 will become 1. Now again this is a common collector. For common collector, what is the current gain highest among three configuration? Common base का होता है अल्फा, common emitter का होता है बीटा और HFE, और कॉमन कलेक्टर का होता है 1 प्लस बीटा और 1 प्लस HFE. तो ये है करंट गेन I0 अपॉन I0 2, I0 अपॉन I0 1 और II 2. देखिए जो फर्स्ट स्टेज का जो आउटपुट करंट है ना, वो इसके लिए इनपुट है, तो ये आपका रेशियो आ गया 1 प्लस HFE. नाउ व्हाट इज द इनपुट रेजिस्टेंस फॉर कॉमन कलेक्टर? तो अप्रोक्सीमेटली इट इज गिवन बाय 1 प्लस HFE टाइम्स ऑफ RE. व्हाट इज द RE? लोड रेजिस्टेंस फॉर दिस. ये सेकेंड स्टेज का लोड है, एंड व्हाट इज द इनपुट रेजिस्टेंस अप टू दिस पॉइंट? 1 प्लस HFE टाइम्स ऑफ RE. नाउ दिस इज ऑल फॉर सेकेंड स्टेज. नाउ व्हाट इज फॉर द फर्स्ट स्टेज? तो दिस RI2 फॉर द सेकेंड स्टेज विल बिकम लोड फॉर द फर्स्ट स्टेज. तो व्हाट इज द RI2 और RL1? 1 प्लस HFE टाइम्स ऑफ RE. नाउ what is the voltage gain for the first one? V01 upon Vi, that is 1, because common collector voltage gain is 1. What is the current gain for the first stage? It will become II2, that is the output of this, or I01 upon IB1, that is nothing but 1 plus HFE. Again ये भी आ गया 1 plus HFE AI1. अब आती है बात इनपुट रेजिस्टेंस, जो सबसे इंपॉर्टेंट है. वो हो जाएगा 1 plus HFE टाइम्स ऑफ RL1. 1 plus HFE times of RL1. What is the resistance up to this point? RL1. But what is the RL1? 1 plus HFE times of RE. अब आते हैं नेक्स्ट पेज पर. तो जब मैं इनपुट रेजिस्टेंस निकाल रहा हूं, तो 1 plus HFE into RL1, that is 1 plus HFE RE, it will become 1 plus HFE square times of RE. Now if suppose HFE is only 49, this is the almost lowest value of the HFE, then what RE is 1 kilo ohm, put here. So 1 plus 49, 50 square will become what? 50 square, 2500 kilo ohm, means 2.5 mega ohm. It is very, very high input resistance, and that's why Darlington pair is used as a high input resistance device. Okay. Second important thing, what about the overall current gain? Current gain will become I naught upon IB1, that is the I naught upon IB1. This is nothing but current gain or multiplication of the current gain of the first stage and second stage. Then it will become 1 plus HFE square. Okay. Now, if suppose HFE is 199, we can take up to what 199, that is the value of the beta. You can take 49, 99, 199 and so on. Normally we are having this is the highest value. 199 plus 1 is what? 200. What is the square of the 200? 40,000. And that is the value of the effective current gain, or effective current gain is also called beta effective or what? HFE effective. So for this, the current gain is very high, and that's why it is called what? Super beta transistor. What is the name of this? Super beta transistor, because the current gain is very high. So input resistance is very high, current gain is very high, and what about the voltage gain? It is 1. Voltage gain is 1. Why? Because first stage voltage gain is 1, for second stage voltage gain is nearly equal to 1, then overall voltage gain is nearly equal to what? 1. Right? And therefore it is used as what? Buffer. जैसा एमिटर फॉलोअर को यूज करते हैं, वोल्टेज फॉलोअर को यूज करते हैं, सोर्स फॉलोअर को यूज करते हैं, वैसे ही वी आर यूजिंग डार्लिंगटन पेयर एज बफर, एज अ हाई इनपुट रेजिस्टेंस डिवाइस with very high current gain. Okay, this is all about Darlington pair. Now guys, remember, if suppose we are using the n stages in cascade, then it will become 1 plus HFE raised to power n into RE. For 2 stages 1 plus HFE square, 3 stages 1 plus HFE cube and so on, and current gain will become 1 plus HFE raised to power n. But normally we are not connecting more than 3 stages. Right? 3 or more than 3 stages, we are not making the Darlington pair. कितने का यूज करते हैं? 2 का, कॉमन कलेक्टर फॉलोड बाय कॉमन कलेक्टर. 3 or more stages are not preferable. Why? If you have the answer, give me answer in comments box. If you want to get answer, then please ask me on comments box. Okay? तो आपको पूछना है, आप पूछ लीजिए, और अगर आपको पता है तो comments box में या हमारे टेलीग्राम चैनल पर आंसर जरूर दीजिएगा. Now guys, this is the part of what journey to gate, how to build concept, daily ka funda. Here we are discussing the concepts and theory, daily ka dose. Here we are discussing the related questions from previous year question set or from what standard textbook. Way to success. Then this is the journey to gate. If you want any session on particular topic, then suggest me on my telegram channel, that is Electronics by Sanjay Rathi. That is link is given in description. This is my telegram channel, Electronics by Sanjay Rathi. And then finally guys, thank you for attending the session. Subscribe our channel now.